ideaCity, the smartest people, the biggest ideas.
One of the arguments for continuing the very costly pursuit of space exploration is that the technology developed has applications on Earth. David Lavery is also a specialist in remote exploration by robotic systems and a strong advocate for robotic education. Dave's machines have done microsurgery on human eyeballs and have gone all the way to Mars. And on a personal note, David sleeps 3 hours a night and drinks a lot of Diet Coke. Still, he manages a $1 billion program. David Lavery. Thanks, David.
Thank you all very much. What I want to talk to you about today is to try to give an example. You know, Rich has done a wonderful job of sort of forecasting out into the future where some of these technologies may lead, where computer science may end in terms of its effect on humanity, where artificial intelligence could lead, what robots could be doing 20, 30, 40 years in the future. What I want to do is bring things back just a little bit and talk about some of the things that are going on right now, very concrete examples, and form a little bit of a counterpoint to what Rich said, in that, in one sense, some of the robots that we have out exploring space right now are wonderfully advanced. In another sense, they are some of the most amazingly stupid devices you will ever come across. I have to go back 15 years to some work that was going on at the Jet Propulsion Lab. This is Robbie. Robbie is about 3 meters long, 2 meters tall. It weighs just over 1 metric ton. These tires are about 1 meter tall each. The big gold box in the center of the machine is all full of computers. The way Robbie would work, and Robbie was being built, by the way, by the best robotic scientists in the world at that time, and they were designing this system as part of the Mars Rover sample return mission, which is something we thought we were going to fly in the early 1990s. And the intent was that Robbie was going to be flown to Mars, would drive around for 5 years, would drive over 100 kilometers all by itself, pick up about 5 kilograms of samples, stuff them inside a little rocket, and send them back to Earth. And the entire project was going to cost about $5 billion US. Now, the way that Robbie worked was sort of interesting, because what would happen is that little bar that's across the top had 4 cameras on it. What Robbie would do is take a picture of what was in front of him, study that picture very carefully. The image would be processed by all of the computers inside that gold box for about an hour, and over the course of the hour, what would happen is Robbie would discern the entire scene in front of it, do stereo correlation to determine in 3 dimensions what objects were where, what obstacles were where, figure the most optimum path for the next 10 meters of its progress through that set of obstacles, and after doing that and the speed of the computers that we had at that time, it took an hour. After computing for an hour and finding the most optimal 10-meter path in front of it, it would step forward 1 meter. Then it would stop and do it all again. For the next hour, it would sit there, look, think, discern, stereo correlate. Ah, I got a solution, best solution possible, let's go forward 1 meter. If you do the math, 5 meters, 100 kilometers, 1 meter per hour doesn't work. Nobody bothered to figure that part out. But they got really excited about the fact that here they were working on this big, wonderful project, the world's best computer scientists, world's best robotic scientists working at the Jet Propulsion Lab, 3 meters long, 2 meters tall, 1 metric ton, $5 billion US. And in one summer in 1991, a young student came out to JPL as an intern named Colin Engel. Colin sat there and said, "This is really cool. Can I work on the project with you guys?" World's best roboticist said, "We are the world's best roboticists. You're a student. Go away, kid. You bother me." Colin said, "Okay, tell you what. If I can't actually work on the project with you, can I at least come and intern with you and just sit off in the corner and watch what you're doing? It's so exciting that I want to be part of the project. Please, can you tell me how, or give me an opportunity just to sit there and watch what you guys are doing? I'll stay out of the way, I promise." And they said, "Okay, fine." They were getting really tired of him at that point. They said, "This is the only way we're going to get rid of him. We'll stick him off the corner, we'll give him a desk, we'll let him sit there and watch us, and he can like fetch tools or something for us." They spent the entire summer working on Robbie, and they got it to the point where, one step at a time, 1 hour at a time, Robbie could make its way across the field strewn with small pebbles and boulders about this big, about the size of this stage in the course of a day. And if they really, really worked hard at it, by the end of the summer, they might be able to have that little gripper on the front, reach down on the floor, and pick up an object about this size. And that was about 12 instruction cycles, which was an additional 12 hours. Colin watched all of this, And at the end of the summer, he said, wow, this has been really, really cool. I've been watching what you guys are doing. You've been working on Robbie. 3 meters long, 2 meters tall, metric ton, 5 years on Mars, 100 kilometers, $5 billion. This has been really neat. I've learned so much. I have to go back to school now. Before I go back, can I show you what I've been working on over in the corner? Okay, now you've noticed I haven't said anything about the other vehicle yet. The other vehicle is Tooth. Tooth was built over the course of the summer by Colin Engel with a little help from a guy named Dave Miller and Ron Gott for about $500 worth of parts from Radio Shack. That is the chassis of an RC, little RC car that you can buy at Radio Shack, and a couple of electronics dumped on board, some stuff from DigiKey from a catalog. What Tooth would do is Colin sat there and got all the scientists that were working on Robbie, they got them all around, put Tooth on the floor, turned Tooth on, and what Tooth would do would just completely ignore the environment. It wouldn't study the environment, would not optimize a path, didn't look at what was going, it just drove and bumped into things. And it drove and bumped into things, and when it did bump into something, those two little pinchers on the front would close. And it would close and try to lift things up. When it tried to lift things up, if it couldn't lift it up, it would assume, this is like a leg of a chair. I'm going to ignore it, let go, and keep driving. If it could lift it up, what we had done is sort of taken a whole bunch of little styrofoam hockey pucks and sort of thrown them all about the floor. I've got a styrofoam hockey puck. This is what I'm after. Then it had a little set of photosensors on top. We'd look for the brightest place in the room. We put a light bulb on the floor. So it'll look for the light bulb and find the brightest place in the room, drive to the light bulb, open its pinchers, drop the hockey puck, and then say, okay, now I'm going to do it again. And it would randomly drive around just waiting to bump into things. If you left Tooth alone in the room long enough with 100 hockey pucks scattered about the room and left him alone long enough and came back, eventually you would find a big pile of styrofoam hockey pucks sitting right next to the light bulb and Tooth off wandering about the floor somewhere looking for more hockey pucks. If you stood there, it'd eventually come up and bump into you and sort of try to lift up your foot, and it wouldn't, and then just go on. And all the scientists that were sitting there working on Robbie, 2 meters tall, 3 meters long, 5 years on Mars, 100 kilometers, $5 billion, said, wow, Colin, that's really cool. Hey, before you go back to school, would you do one thing? Tell us how you did that. Science and technology is an amazing, wonderful subject. It's full of enlightening opportunities to create, to form new ideas, to build a society, to advance our culture, to affect the world. But the simple reality is behind all of it, there are people. There are students like Colin, there are individuals, one person at a time, that make massive, huge differences. One little student who is 21 years old at the time fundamentally told the entire space robotics community of the world, everything you're doing is you need to find another way to do it. And he was right. He was absolutely right. What Colin did is teach a bunch of the world's best roboticists how to build subsumption architecture robots. Fancy phrase that basically means robots that mimic insects. Don't try to understand the entire world when all you're trying to do is pick up a hockey puck. The net result of that is 7 years later, right here, the great-great-great-great-great-great-granddaughter of Tooth was Sojourner, which landed on Mars in 1997, a subsumption architecture rover that was a direct descendant of Colin's work. The neat part about it is that project, with Mars Pathfinder, the entire cost, soup to nuts, of the whole mission was not $5 billion US, it was $250 million. Still a lot of money. However, at the time, it's about the same amount of money that was spent on the movie Waterworld, and to be honest, we were in the box offices longer. Then the descendant of Sojourner was the Mars Pathfinder rovers, Spirit and Opportunity, which are operating now. These two rovers that were originally designed to last just 90 days, they're now well in excess of 500 days each. They were designed, if we were extraordinarily lucky, they'd return about maybe 8,000 or 9,000 pictures. Right now, the total photographic return from the two missions is in excess of 90,000 photographs. They were intended to drive about 600 meters apiece. Now, in total, we're well in excess of 10 kilometers. they're lasting far, far better than we ever thought that they would, and continue to provide a wonderful science return. Oh, by the way, just the end of the final Colin Engel story is, you want to know what Colin is doing now? Of course, people assume that we hired him and we brought him into JPL, he's building robots for us now. No. He actually went out and co-founded with Rod Brooks, iRobot, the little Roomba robots. That's Colin's company. They just sold their 2.5 millionth Roomba robot. He's now filthy stinking rich, and I'm jealous. We get to Mars, and this is one of the first images we see. And this is actually, of the 90,000 images, this is my personal favorite. This is the one that I love the most. Because if you look at here, look at this image, the first thing that we saw when this image came down, our immediate reaction was, wow, Arizona. But then we noticed something. If you look on the right-hand side of the image, there's a couple of dark splotches about midway down the image, and there's 1, 2, 3, and there's sort of a little curved path, and there's another one right down here in the corner. What those are the bounce marks from the airbags that surround the spacecraft as we came in and landed. That as these airbags that were fully inflated and we dropped from a height and we bounced across the surface of Mars in the final steps of the landing process, those are the places where we bounced. Now, think about what this really is. Philosophically, understand what's just happened. Earth has arrived and put our mark on another planet. We've left our footprints on another planet for the first time. Now, this isn't the first time we've landed on Mars, but it's the first time we've seen a disturbed surface where we've made a physical difference, an impact, literally, on the surface, and been able to look back at it and understand that we've changed that place for the first time. Philosophically, I love this photograph. Another one of my favorites, a dust devil on Mars. The theory all said that they should exist. We knew that there was weather on Mars. We knew weather patterns were prevalent across the place. The first photographic evidence ever that small localized weather patterns really are there. The theory said fine, but here's the proof that simple things like dust devils can exist on other planets. Sunset on Mars. Mars sky most of the time is pink. It does have the right hinge from the planet that you would expect, except in the evening and early in the morning, there's a distinct blue cast to it, so you do get a little bit of a vision of home. And actually, the outstrip here on the left-hand side, if you look closely, about halfway up, there's a little tiny white dot. That's Earth from Mars. So there's proof that we exist. Thank
you. Get the latest Idealist news, presenter information, and watch streaming video at www.ideacityonline.com.